Hello, Professor. This is Kunal Shah from Team Fold'em, and here basically me and my team would like to present the way in which the logic behind what we have done in the GameCock drone service project, what we are supposed to handle. Now, in this case, I've just tried to keep. Now, this is the first sheet where we have done bit of analysis on the Excel part of it, and then we have developed a logic here, and then probably we'll give you a brief of how this logic works by taking a small part of this data rather than considering the whole data as such. Along with this thing, we've also uh, written the code in Excel VBA, which will execute the same logic at the background, and it will give us a complete data of the sequence in which the drone should move from one point to other and reach the final destination, that's your back to the headquarters. So let me start with the explanation first. The first four rows is the data what you have already shared with us, and it consists of those 125 locations where the drone is supposed to send its uh, package. And in this we have added one more extra row, which is the zero position or the zero drop ID sequence, which we have considered as your headquarter location 11. Then what we have done is we have transposed the drop sequence ID from the row F1 till the end, which you can see it here somewhere till EA. So we have transposed that thing, and we have taken into horizontal axis. So now we have the X and Y axis, and then we have calculated distance of each point with the other point. So we have tried to calculate the total distance matrix out of it. Now the distance matrix is calculated based on the formula what you shared. So in every row there'll be a point which is a 0 0. So you're trying to calculate distance from the point to the same point. So that's the reason this point is 0 0. But yes, there are some instances where you have two packages to be delivered at the same point. So even that location, the distance would be 0 0. So these are the uh, caveats what we have considered in our code, and we are going to handle these kind of corner cases as well. Now here we have tried to calculate the distance. So just giving a brief how if the package 01, the distance from the headquarter is 29.15. So that's the distance between these 2 points. Now just to explain this logic, right, rather than taking this whole sheet into consideration, I have considered a smaller version in which I have taken only 6 points as my examples. So it's from 1 to 0.6, and again from 1 to 0.6. So here I'll be explaining you how we reach at different locations based on a small set of database. So it becomes easy to understand what we are doing exactly. So to start off with, we'll start with the location 1, which is our headquarters. I'll mark it yellow, and at the same time, right, this is the first location for us. From here onwards, I'll scroll my data. I'll scan my data in this column, in which I'll try to find the minimum distance of any other point with respect to the headquarters. So here when I scan this section, I'll get this as my data. So I have created another array in the logic where I'll keep on storing values pertaining to this location. So here basically I'll first of all I'll uh, store this data, which is 27.02. I'll again store the corresponding drop sequence ID. I'll store my x-axis coordinate for that, and my y-axis coordinate for that. So here basically I have these 4 points which I have stored, right? So this is my first location where my drone should go from the headquarters. Once at this position, the next part of the logic is I'll identify this number and I'll search for this drop sequence ID in my corresponding row. So in this case, I am here. So this is the next destination where I'll reach. So here onwards, again, I'll check for the minimum distance in this column. So in this case, the minimum distance is 27.02. I'll again highlight this. Now this 27.02 is basically the headquarters. So I've already considered this distance. So I'll ignore this point. So I again reject this. I'll look out for the next higher distance, which is the it should be lowest among these two. So that should be like somewhere 27.46. So this is the next location where I'm supposed to go. So I'll highlight this point here, and I'll take the corresponding data. So let me take the values again. 27.46. The corresponding ID is this. Corresponding x-axis is for 3 is this, and for y is this. So this is the second location where I'll be reaching once I start delivering my packages. So when I'm on this row, that is I'm on this drop sequence ID 3, the next step would be search for the corresponding drop sequence ID in the first row. So this is where I reach here. Now I'll find again the minimum distance. Yeah, one point again I missed out here. The minimum point distance would be 0, which is at the same point. So I'll ignore that value and I'll take the higher value than that. So the next location is 6.7. So this would be the next location where I'm supposed to go. So from 6.7, I'll write that value here. So it will give me my next location where I'm supposed to go. So it is the second. Then I have my x coordinate. I'll have my y coordinate. Right. So from 2, I'll reach here. I'll look out for the distance. Here again, 0, 0 is the same location. I ignore it. 6.7 is already there because like you have already delivered your drop sequence ID 3. So we'll ignore this as well. The next point is 13.6. So this is where we are supposed to go. But again, this is not done. So I'll take this location, reach here, 13.6. Corresponding my address is 4. X-axis is 50. Y-axis is 40. Right. So from 4th location, we'll move ahead and we'll reach here at this point. Now again, here we'll start looking out for the minimum value. 0, 0 ignored. Then we have 13.6, which is ID 2, and it's already been considered. We'll see in this history. We'll compare it with the values in this table, and it's already done. So we'll ignore this as well. We'll go to the next location. Is 24.07. Sorry, this location. So this would be the next distance for us in this sequence. Here we'll have a sequence ID as 5. I'll just highlight this as well. Right. For 5, my x is 27, y is 49. Now from here we go to channel 5, which is here, this point. This is ignored. This is ignored. These two are again ignored. We have 29 left as our next destination. I'll take that. Which is again number 1. Then you have x-axis as 4, y-axis as 3. Oh, sorry. Okay, So now here we are, like we have completed the loop and we have reached all the locations, right? So it's like 6. And meanwhile there is a separate counter in the loop which will calculate like the number of steps we have, number of iterations we have gone through. So it will basically be adding everything. And once you are at the end, which is like in actual case is 125, here it is like 6. Once you are at the 6, it should take us back to the home position. So from this location we are supposed to go back here, which will take us to 00 at this point. This is like the drop sequence ID and the corresponding locations X and Y. So this is the table we get when we actually finish off our exercise, or basically uh, finding the sequence, like how we are going to follow. Now what we have done, we have taken this X and the Y axis table as references, and we have drawn a scattered plot. So this is a scattered plot which gives us like where are those different locations, and following this thing, right, we just need to uh, identify, like we have drawn a sequence line which basically connects all these points and we get a final answer. So this is the exercise what we have executed, and we have reached to the final optimized path of how we have reached to different locations. So that's it. This is how like we have executed. Thank you very much.